equations here. That's our goal here for today. So, substitution and elimination are the two methods. We'll do substitution on this one, and then we'll do elimination on this one. Okay? So first off, I want to change this equation here a little bit. Let's make this 3x plus 4y equals 11, and 2x plus y equals 4. So we'll just change those a little bit so it works out a little bit nicer. Okay. So remember, our goal here when you solve a system is to find the ordered pair. So in both of these, we want to find an xy coordinate. Okay? Remember that. So you can use the elimination or the substitution method to solve a system of equations when it's easy to isolate one of the variables. So there's really one variable I would consider easy to isolate. I can just subtract 2x here. That would be the easy variable to solve for. Here I'd have to subtract 3x and divide by 4. So if you have a coefficient of 1, I'm saying it's an easy variable to solve for. These aren't easy to solve for. Okay? So after isolating the variable, substitute for that variable into the other equation. So we have to pick one of these equations. I'm going to call this equation 1. Top one we'll call equation 1, and the bottom one we'll call equation 2. So I'm going to solve for the y in equation 2. So just subtracting 2x. So I'm going to rewrite. So y equals 4 minus 2x, or negative 2x plus 4. That is equation 2. Here is equation 1. 3x plus 4y equals 11. So, isolate one of the variables. After isolating, substitute for that variable in the other equation. So I want to somehow plug the second equation into the first. So, y equals 4 minus 2x. Well, I don't want this y here. I'm going to plug in an expression for x that it's equal to, 4 minus 2x. So 3x from the first equation plus 4 times y. Well, I want to take out the y and plug in an expression of x that's equal to y. So again, here's the first, this is the first equation with the second subbed into it. So 3x plus 4 times 4 minus 2x equals 11. So let's solve that. 3x plus 16 minus 8x equals 11. So negative 5x equals negative 5, x equals 1. So we are halfway done. We have half of our solution. So our solution to a system is an ordered pair that works in both. So we isolated it, we substituted it into the other equation, then solve for the other variable. So you can take this value of x and plug it either into the first equation, right here, or the second equation. So I'm going to plug it into the first equation. So 3 times the x value, 1, plus 4y equals 11. So now I've got it where I have I should have be able to solve for the y variable. So I'm going to subtract 3, 4y equals 8, y equals 2. That's the ordered pair that works in both equations. Okay? So that's the substitution method. So let's look at the elimination method. Okay? So the elimination method, this one right here, what we're going to do is we're going to add the x's and y's together and add the constants together. Now in this case, if you add them together, those are opposites that add up to nothing. So you have 5y equal to 25. So the elimination method, your goal in the elimination method is to make sure that one of the coefficients are opposite. It just so happened that these were opposite to begin with. I gave you an easy one to start with. So if they're opposite, you add them together. That's 0x. That's 5y equals 25. You don't have any x left, so you have y equal to 5. So how do you think we're going to find the other value of the other part of the solution? We're going to plug y of 5 either into the second or the first and solve for x. So let's plug it into the first equation. So 4x plus 10 equals 9. Subtract 10. Divide by 4. And the answer is not 4, it is 1/4. So you got a fraction for an answer, but you really didn't have to do any work to get that value. It's just -1/4. So -1/4. So let's check them out. So 4 times -1/4 would be -1. And 2 times 5 is 10. -1 plus 10 is 9. -4 times -1/4. I'm just checking it, plugging it in. You don't have to do that. I'm just showing you that it works. And so that would be +1 plus 15 is 16. That would work. So we're golden. We're good to go. Okay, so let's look at the next page here, and let's take a system of equations that we're going to do by elimination, but we can't just add these equations together. So if we added them together, I don't want you to do this, but if you did, you don't get any variables to cancel off. Okay, so there is lots of ways of doing it, but my suggestion is decide which variable you want to cancel off. So let's say that we wanted to cancel off the x's. So what you can do then is you can take the coefficient from the first equation and multiply everything in the second equation times it. So we're going to multiply the second equation times 2. So ignore these for a second. Now, think about it. The coefficient here is going to be 6. I want this to be a -6. So I'm going to multiply by -3. Now, you could have multiplied the bottom by -2 and the top by +3. But in either case, we're going to get the coefficients to be opposite. So again, multiply this equation by the coefficient of that guy, and multiply this equation by the coefficient of this guy. Just try to make sure that the coefficients are opposites. So let's see what happens. The bottom equation is 6x plus 10y equals -10. The top equation is -6x minus 21y equals -12. Now see, these coefficients are opposite. So it's -11y equals -22, y equals 2. So what's our goal here? Our goal is to find the solution to the system. The solution of the system is an ordered pair. So once you find, in every one of these, once you find one of the variables, you got to plug it into one of the equations, one of the original equations. I'm choosing the first equation. So I'm going to plug in y into the first equation. Right there. Could have done the second equation, doesn't matter. There's your solution to the system. Now, you could have approached this problem differently. You could have said, you know what, I want to cancel out the y's. I want to make the coefficients of the y's opposite. So then I would have multiplied this one by -5 and this one by 7. Now I'm not going to do all of it, but I am going to show you what would happen if you did that. Look what happens now. You get the y's that will cancel off. And you get x equal to -5, and you plug that value in, and you'd find the value for y. Just do it in reverse order. Okay? So either way, I didn't finish it, but we would get the same answer. Okay, let's try this. Hey, look at this guy. Elimination would work because these guys are going to cancel off. That's going to add up to 0x and 0y. Well, that's nothing. Opposites add up to nothing. And then that's nothing. Well, if you get something that is a true statement, you don't have x equals 0, you get 0 equal to 0, that's a true statement. That means that you have what type of system, do you think? One that has a bunch of solutions. A dependent system that has an infinite number of solutions. Over here, very similar, you get a 0 on the left and a 16 on the right. Well, that's false. That's never going to be true. You're never going to have anything that makes this true. This is a inconsistent system. 0 solutions. So there you go. Good luck.